Finally, the last part of our mechanism is a catalyst. The catalyst provides an alternate route for the reaction to occur, and that route will have a lower energy of activation. It is a substance that increases the rate of reaction without itself being consumed, so it's actually reusable. All right, so as the energy of activation goes down, the rate of the reaction will go up. So here are some reaction energy diagrams that show an example of an uncatalyzed reaction. So you see the energy of activation, but if we provide a catalyst that provides a totally new mechanism for the reaction to occur, it can lower the energy of activation. And if it has a lower energy hump to get over, then that reaction can proceed much faster. So an example of a catalyst and a mechanism is a chlorine radical serving in the decomposition of ozone. So if we have a chlorine radical that bumps into an ozone molecule, it can form these things, and then maybe something is helping the oxygen break into oxygen radicals. And then at some point, that intermediate bumps into an oxygen radical, and it can form O2 and release another chlorine radical. And then the ozone can bump into the other oxygen radical and form O2. So the catalyst doesn't appear in the overall equation, but it can appear in the rate law. So let's look at how this cancels. Look at the catalyst. So the catalyst starts, and we see it as a reactant first, and then later it comes back out as a product. So it sort of cancels in this direction. It's the opposite of an intermediate. And see, if it spits back out as a product, it can circle back around and start in the process again. That's why catalysis and the catalysis industry is such an important industry, because they are reusable. All right, so chlorine is a catalyst. Let's get rid of some of this writing. All right, so it cancels, but it cancels as reactant first and then later as a product. So let's go ahead and evaluate the intermediates and the overall reaction. So we have ClO, we have an O2 cancels, and we have oxygen radicals. And I think that's it. So the ClO is an intermediate, the oxygen radicals are an intermediate. Technically, the O2 is not really an intermediate because it's already one of the products, and we just have to have we happen to have an extra one floating around in the molecule. So ClO, the oxygen radicals, and the O2 cancels, but it's part of the reaction. So we get ozone breaking down into oxygen. So ClO and the oxygen radical are intermediates, whereas the chlorine radical is a catalyst.